Hello everyone, as I know you are heading off into functions and ranges and domains and imaginary solutions and the like in math. I wanted to make sure that I didn't completely blow over what I left on the board the other day. And so we talked about recognizing some basic equations and not in their plain vanilla form, if you would. Plus 9x equals 25. Now, on some, one can eventually look at something like this that's got a second order and a first order, second order, and first order of both the x and the y and realize it is a circle. If you remember, the basic form for a circle is x squared plus y squared equals r squared. More importantly, for an ellipse, as you're dealing with ellipsoid, it's x squared over a plus y squared over b equals 1. And how one goes about getting that is based on something called flattening and the like. So this, we said, was a circle, and this one was some sort of ellipse with the a and the b, I think, being those two distances of the major axes. All right, so going back to this, how do we then make that into something that we can recognize of the format, the true format of a circle, which is x minus h squared plus y minus k squared equals r squared. And let me point out, in most graphing software, but not your calculator, you can graph that by just punching it in. So whether it is Wolfram Alpha, just basically graph or plot, that will do it. Mathematica, GCalc 3 perhaps, but not all of them, because they do not like dealing some of them, the things that are not functions. And a function is something that has only one y for every single x, and you know this is not the case for a circle. So how do you go about doing that? It's really a great thing, completing the square. One of my favorite things of all time, I think, in terms of proofs. But we're going to do the mathematics and the algebra here only and come back to what the complete the square means. So what we do here is we leave a blank for the completing the square. And so what we do here is, to make this a complete square, x squared plus 4x, we take half of this and then we square it. And so half of that is 2, square it again is 4, and we add 4 over here. Remembering, but the equality means you must balance things. X squared plus 9x, half of 9 is 3, squared is 9. Equals 25 plus 9. Now what you have in effect is x plus 2 squared plus y plus 3 squared equals 38. And if you remember the format of x minus h, so this is a circle centered at minus 2 and minus 3 with a radius of the square root of 38, the positive version of that. I guess the absolute value of the square root of 38. Okay, so that is completing the square, and somewhat more important, recognizing that if you have a format with a square and a single and a square and a single, it's probably going to end up being a circle. Probably going to end up being a circle or an ellipse, one of the two. So we'll leave it at that. Thanks for listening. Well, no, let's not leave it at that. Who we kidding? We got to go out to Wolfram Alpha. Let's see if I can do that here through Google Chrome. And we're going to go www.wolframalpha. Hopefully. If I had my Apple side running, and I'm going to do now, say graph or plot x squared plus 4x plus y squared plus 9x equals 9, or equals 25. Now, point out, after I hit this, we're going to go back in 25, sorry. We're going to go back and look at the syntax that comes out of this. That's what we wanted to do. We wanted to recognize, really, or plot, but we go ahead and hit equal here, and we'll see what happens. Natural language comes out, and there you have it. And remember, again, with this program, we'll really have to look at the axes. All right, we really have to look and see. This is not a great thing to get. It's an implicit plot. The problem is, in fact, that it is interesting as we highlight that. It is really a circle. That just doesn't look like a circle. And what we don't have, I'm going to try one more here. We'll try graph. And it's, in this case, it's disguising the syntax, but it's going to show it to us a little bit. So plot, there it is again. And of course, the axes here are screwed up. And so that's something you learn in your calculator. We're going to look at or figure out how we're going to make Wolfram Alpha truly graph and something that's a circle, so it looks like a circle. Once again, it is tough to get this to graph in your calculators. Kind of surprising that it doesn't have a better way to do that, but it does not deal with non-functions very well. Thanks for listening.